Another reaction of aldehydes and ketones is the addition of the alcohol in presence of an acid to the carbonyl. This is called an alcohol addition to aldehydes and ketones. And during this process, I will form two things. I will form a hemi-acetal, and I'm going to form an acetal product. Okay? The reaction is going to happen over two steps. Step 1 and step 2. In every step, I am adding 1 mole of the alcohol. Okay? So if I want both the steps to happen at the same time, I would say excess of the alcohol. So in the first step, I add 1 mole, and in the second step, I add another mole in there. So let's see what are we doing in here. So we're going to start with an aldehyde. I'm going to give an example of an aldehyde and then another example of a ketone. The reaction goes exactly the same. All what you're responsible for is to write the product down. So the reaction, let's all agree that whenever we're working with aldehydes and ketones, your reactive site is the carbon double bond down. So this is where the addition is going to be on. So let's go ahead and highlight that. Your starting material is the aldehyde. Your reagent that you are using to add to the aldehyde is the alcohol. Okay? The alcohol can be any carbon chain alcohol. I'm using here the simplest, which is the methanol. So the reaction goes as such, and the acid is very important in this reaction. It is a catalyst. So I am using sulfuric acid, any acid. This is a catalyst. This speeds up the reaction. If it is not there, the reaction will take a very long time in order to form. So in this type of reaction, what I am adding is two things. I am adding the OCH3 and I am adding the hydrogen. Okay? The OCH3 is going to add to the carbonyl or to the carbon of the carbonyl. And then the hydrogen is going to add to the oxygen. As simple as that. And you're going to create what we know as an intermediate of the reaction. The intermediate is not the product, but it can be if you're just using 1 mole of the alcohol. You're not using more than that. So I need to specify for you how much you are using of your reagent, because the alcohol is the reagent and the starting material is the aldehyde. So in order to draw the product, I'm going to start with the CH3 here. I'm going to draw it. I no longer have a carbonyl in there because I am adding to the carbon and to the oxygen. So I'm making 2 sigma bonds. I need to break the pi bond. So this double bond no longer is there. So I'm going to make a sigma bond in there, just a 1 bond between the carbon and the oxygen there. Now the oxygen is going to take the hydrogen of the alcohol. So I'm going to end up adding a hydrogen over here, okay? And the OCH3 will add to the carbon. So I need to show that the OCH3 is added to the carbon. See, this is what I am adding. I'm adding the OCH3 and the hydrogen. These belonged to the alcohol, and now they are added to my functional group in there. The hydrogen stays. So this hydrogen that you have for the aldehyde stays over here. And it's so important because this hydrogen tells me that I am starting with an aldehyde. So this hydrogen here, it's going to show that we are starting with an aldehyde, not a ketone. So this hydrogen shows that we are starting with an aldehyde, not a ketone. Okay? Now, this product has a name, and that name is called hemi-acetal. Okay? It's a part acetal. It's a hemi-acetal in there. So a hemi-acetal is an organic compound that has on the same carbon an OR and an OH. Doesn't matter what the R is, it depends on the R of the alcohol that you're working with. We stop here if we are using 1 mole. If we're using more than 1 mole, then we would need to continue. How we are going to do this? It's going to be the second step. So you take the hemiacetal, which is the product of the first step, you put it as a reactant in the second step in there. So this is the same as this one over here, and you react it with another mole of the alcohol. Okay? So with the other mole of the alcohol, what are we doing over here? Simply, we are replacing the OH with the OCH3. This is what we are doing. So let's go ahead and highlight the OCH3 in there. So that OCH3 is going to come and add to the carbon. It's going to add to the carbon in there. And then what you're going to be left with is the OH. Let's put it this way. Okay, let's use a highlight. So what you're going to left with is the OH that is present on the carbon. This OH is going to combine with the leftover hydrogen and create water to be our byproduct. Okay, so the OCH3 here is going to come and add to the carbon. In other words, it's replacing the OH. So my product in this case is going to be a CH3 that is connected to the carbon. This is an OCH3. So what did I do here? I added an OCH3. So that is going to be the OCH3. I replaced the OH. I still have this hydrogen here. Let's highlight. This hydrogen here is a must. It's very nice. It's very important. I still have this hydrogen here. This hydrogen here is very important, and I need to put it just to show that I started with an aldehyde, okay? Plus my byproduct here, which is going to be water. This product that I'm forming here, I'm gonna call it an acetal, okay? So my first step makes the intermediate of the reaction. So that hemiacetal is the intermediate of the reaction in there. It's not the product if I'm using more than 1 mole of the alcohol. It is the product if I'm using 1 mole. Then I need to stop at the hemiacetal. But if I'm using another mole, then I'm going to take the hemiacetal, react it with another mole of the alcohol in presence of an acid in there, and then replace that OH by the OCH3 and create the water as a byproduct in there. And that is going to be my acetal. My acetal are always made up of ORs on the carbon. This is the definition of an acetal. So you have to know that the difference between an acetal and a hemiacetal in here. So an acetal needs to have 2 ORs on the carbon of the carbonyl. On the carbon of the carbonyl in there, okay? So my intermediate in this reaction is an actual hemiacetal, and if I go ahead and use another mole of the alcohol, then I'm going to get my acetal in there. A general representation of the acetal is carbon that is connected to OR, another OR in there, and then a hydrogen, and then an R there. So this one is a general representation of an acetal. Okay, general representation of an acetal here. Let's go ahead and have another example. So let's do an example in there. Let's do an example. So with this example, let's see, okay, 1, 2, 3, 4. This is a 5 carbon aldehyde, and I am reacting it. So the reaction will go as such. I would tell you, you know what, I'm using excess of the alcohol. So let's say here I am using an alcohol that is made up of 2 carbons. Again, the alcohol can be any type of alcohol. It doesn't matter. The R can change. It doesn't matter. But I have to tell you if I'm using excess or if I'm using 1 mole. Excess means 2 moles. Okay. This is what excess is. I can either write it like this or I can write it as XS in there. And this means that I am using excess of the alcohol. So all what you need to do in there, since you see the excess, I need to go all the way to the acetal. To go all the way to the acetal is very easy. All what you need to do is just highlight your carbonyl because this is your reaction site, you guys. Okay. On this carbon, I am adding the OR. So I'm going to add an OR here. So we're going to add the OR to this carbon. We're going to add the OR, another OR. So add another OR to that same carbon in there. And then the oxygen that you see in here is going to turn into water at the end. So my product is always going to be an acetal and water. Okay. Now my OR is what here? This is going to be my OR. So this is going to be my OR in there. It's the OCH2CH3. This is what I am adding. So all what you need to do is just to draw your 5-carbon chain. This is going to be including the carbon of the aldehyde. So that is going to be my 5-carbon chain. Now I've reached the carbon of the aldehyde in here. On that carbon, I'm going to add the OCH2CH3. Notice how did I write it? The connectivity is the oxygen is going to bond with the carbon. So the oxygen there is going to bond with the carbon. So I cannot do CH2CH3 and then, oh, this is wrong. The oxygen is bonding with the carbon, so I'm going to end up having an OR here. I'm going to end up having another OR on that same carbon in there. And of course, don't forget the hydrogen here. This is going to tell me that, you know what, I'm starting with an aldehyde. So that if you go backwards in there, you can break this bond, you have a hydrogen, you can recreate the carbonyl back again, and you are starting with an aldehyde. If I ask you, okay, you made your acetal here, so this one is called an acetal. Okay, go ahead and show me the intermediate, which is the hemiacetal. That's easy, because with the intermediate, I know that I am adding just 1 mole of this. And the double bond O will turn into an OH. So with the intermediate, just show it in brackets in there, having the hemiacetal here, where the carbonyl will change into an OH, and then you're going to end up having your OCH2CH3, and of course you have your hydrogen, and that is going to be the hemiacetal intermediate. Okay, please get used to drawing your acetals and your hemiacetals in there. So this is the general reaction. Aldehydes with 1 mole, you're going to create your hemiacetal. So let's start. If you have an aldehyde in there with a hydrogen, you're going to create your hemiacetal, and the hemiacetal is simply an OR that is connected to the carbon of the carbonyl, or added to the carbon of the carbonyl, and the carbon of the carbonyl, this one, turns into an OH. So that is a hemiacetal, but the hydrogen is a must. So that tells me that I'm starting with an aldehyde in there. And then if I add another mole, then the OH is going to turn into another OR. There you go. And hydrogen again is a must, and that is going to be my acetal. The reaction is going to carry the same with ketones. So here I do have examples of ketones there. Again, it's going to be the same. Everything is going to be the same. So I'm starting with a ketone, and the reaction is 2 steps. So if I use 1 mole of the alcohol and then I use another mole of the alcohol, then in this case, the alcohol, the OR. So it doesn't matter. I said that the OR can be any OR in there. So we said that the OR is going to come and add to the carbon, and the hydrogen is going to add to the oxygen. So I'm going to create now my hemi, but it's not going to be an acetal anymore. We're going to call it a hemiketal, okay, because I'm starting from a ketone. It's an acetal because I was starting from an aldehyde. Now it's a ketal because I'm starting with a ketal. So I added a hydrogen in there. And then on that same carbon, see what I'm doing? On that same carbon, what did I add? I added the oxygen and then the isopropyl group. So I need to make a connection between the oxygen and this carbon. Please pay attention to that. So I need to make a connection between the oxygen and the isopropyl group. It's going to be an OR addition, not an OR addition. The connection is so important. And there, notice that on this carbon, I don't have a hydrogen here. I have a CH3 because I'm starting with a ketone. So this one now, I'm going to name it as a hemi-ketal. So this one is going to be a hemi-ketal. What does that mean? There is no presence of a hydrogen here. This means that this is starting from a ketone and not an aldehyde. The general representation of a hemi-ketal is this. So you have an OR and an OH. So that is the general representation of the hemi-ketal in there. Now the second step, I'm using another mole of that alcohol. So that is another 1 mole of that alcohol here. So I'm going to take my hemi-ketal and I'm going to react it again with the 1 mole. And I'm going to do the same in there as I did before. So that OR from the oxygen, see, from the oxygen, it's going to add to the carbon. And then the leftover hydrogen here will bond with the OH there and will make me water. So I'm going to end up getting my ketal in this case. So I'm going to here have my OR. I'm going to create another OR in there. There you go. You can write it in any direction you want. Plus, I have my water. Guys, pay attention here. I do have a chain of 4 carbons. I have here a chain of 4 carbons. I am not adding any carbon. All I am doing is that on the carbon of the carbonyl, I am adding 2 ORs. So at the end, I'm going to end up having 2 ORs, and my product here is going to be the ketal product. So the reaction goes as such. You do have a ketone in there. Let's write the ketone. This is an R. This is another R. You're reacting it with excess of the alcohol. I'm just going to put it as an R prime and an R double prime just to differentiate from this R there. It's going to be excess. So I know that I'm going to go all the way into the ketal. Actually, take out this excess in there. Because I went into the hemi-ketal. So I'm going to be using 1 mole. Okay. And I'm going to form my hemi-ketal and then another 1 mole, and then I'm going to get the ketal. To go from the ketone to the ketal, you need to use excess of the alcohol. So you actually don't isolate the hemi-acetal. You pass by it, but you don't isolate it. So with the hemi-ketal, I am going to form an RC, an OR, an OH, and then my R double prime. This is the R prime, and with another mole of the alcohol that's going to replace that OH, and I'm going to end up getting my OR here, my OR there, and then the rest of the molecule, and this is going to be my ketal. Let's go ahead and have an example. Cyclohexanone, this is a ketone, so I know that my reaction is going to be on the carbonyl, on the carbon of the carbonyl in there. So all I am doing, I'm using excess, right? So no need for me to show the hemi-ketal. All I need to show is the ketal. So I'm going to take this part of the OR, and I'm going to go ahead and add it here, and I'm going to go ahead and add it there, and the oxygen is going to be turned into water. So here you go. I will have my cyclohexane. This over here is going to be my my OCH2CH3, and then I'm going to end up having an OCH2CH3, plus I'm going to have my water in there. See what I did? I added the O, not just the CH2CH3, the OCH2CH3 on this carbon, another OCH2CH3 on that same carbon, and then the oxygen turned into simply water. My intermediate in the reaction is going to be my hemiketal. So if I want to go ahead and draw the hemiketal, instead of adding two OCH3s, just change one of them into an OH. And you're going to have your OCH2CH3 there, and the other one is going to be the OH, and that is going to be your intermediate. We call it an intermediate. The definition of the intermediate is that you cannot isolate. So the reaction continues, and you are going to form your final product in this case, which is going to be the ketal